record this one. I started recording from now. So thanks for letting me know. And about the group project, is it okay to group with friends and other lab class? I will explain this one. Yes, it is okay to actually, you can select your own group. So I will explain it in detail. So as I mentioned, this is a project-based course. We are going to work on a multidisciplinary civil engineering project. Here you can see the main objectives of this course. The course will give you the opportunity to undertake a practical civil engineering project. This civil engineering project actually has three parts. One is coming from the geotech group, the other one is from pavement engineering, and another part will be about the structural design, and it is related to structural engineering. So it is a realistic civil engineering project, multidisciplinary project, and it involves structural, geotech, as well as pavement engineering. So, and the aim is to use these skills that you learned during the previous civil engineering subjects, your previous civil engineering subjects. And we are going to use several Australian standards for structural design, for the actually for pavement design, as well as for determination of the different types of load, dead load, live load, and wind load. And another objective is that you need to write a technical report similar to the one that you need to actually is required in the industry. So we are going to actually learn how to write project reports in this course. And the main aim of the course is to further develop your research, teamwork, and self-directed learning skills. As you can guess, the structure of the course is different from what you had before during your undergrad program. This course requires lots of actually teamwork, research, and also self-learning. You need to go through different references, different guidelines, standards, and somehow find the answers to your questions related to the project. So we are going to tell you, me and my demonstrator teams are going to give you the fundamentals. We are going to help you in this process, but you are the main person, you are the main people who needs, main engineers who need to solve this complex multidisciplinary civil engineering project. So you need to work in groups of 3 for the most part of the course. You can decide about your group members. So one member of each group should send the details of the group, names and ZID, to this email address, design.cvn@gmail.com. And please send it to me by Friday, this Friday, by the end of this week at 9 p.m. Members of the group are suggested to be in the same workshop class. This is not compulsory. It is suggested due to the restrictions that we have. This year we decided to not make this compulsory. So, but it would be better if you are in the same demonstration class, so you can discuss the problem with each other, in particular in face-to-face classes. So you can decide about the group and send me the email by this date. If you don't send it to me, then I will randomly allocate you to the groups. You already know about the time. The lecture is on Tuesday from 6 to 8, and the lecture will be recorded for you. And also the workshops, there are 2 time slots. One is on Thursday, the face-to-face one from 10 a.m. to 12 p.m. And the class on Fridays are the online ones, the online demonstration classes from 6 to 8 p.m. So during the lectures, I'm going to provide you with the key information on the project, on different aspects of the project. I'm going to explain about the standards, which part of the standards we are going to use, and going through that part of the standard for you and explain it to you. During the workshop, you are going to work on the project and ask your questions from the demonstrators. The demonstrator are going to help you to solve the problems that you have, to address your questions. But this course requires lots of self-study. As a group, you need to spend a lot of time to go through different standard, different references, review the literature. Even you can go and see senior engineers and ask your questions and the challenges that you have in the project and get advice from them. So much of your group project will require self-research and self-study. But about the project that we actually developed this year for you. The project is one of the most important projects in Australia. As you know, as you might know, in Australia, 99% by volume of international trade is transported by sea and in containers. So container trade is growing steadily in Australia with particularly strong growth over the last decade. Here you can see the Port Botany in Sydney. And if I want to give you an example about this Port Botany, this Port Botany actually started working in 1970. It was opened in 1970. And the container trade at that time was something around 175,000 TEUs. TEUs is the number of the container. It's actually an equivalent unit. A 20-foot length container is called TEU. So it was about 175,000 container at that time. Until 2010, this value increased to something around 2 million containers. And from 2010 to 2020, this increased to 3 million containers. So within just one decade, the value increased from 2 to 3 million. This is a huge actually increase. And they expect that this value will increase to 4 million until by 2030. So what does it mean? It means that all the time we need to develop new container ports for the country. We need to expand the existing container ports for the trade, for import and export trades. And this is very critical infrastructure project in Australia. So about the Port Botany, why do I explain about Port Botany? Because the project that we are going to go through is similar to the project, it's Port Botany expansion project. So I will explain more details about this expansion project. But if I want to explain about the significance and importance of this port in Sydney, it is interesting to know that about 42% of all goods that you have at home in Sydney are imported from Port Botany, imported in containers through Port Botany. And this includes food, beverages, floor coverings, mattress paints, fridges, and etc. Also, Port Botany is the largest bulk liquid and gas port in New South Wales, with about 5.5 million kiloliters of bulk liquids and gas import and export each year. So this is a huge amount. What about the project, about the Port Botany expansion project? The aim of the project was to double the Port Botany's container handling capacity. It took about 8 years it started in 2005 and finished in 2013. About 5 years it took, and the budget for this project was about $1 billion, and 400 people employed during the construction of this. This project included the construction of a new terminal that you can see in the figure here. It was the construction of shipping wharves. In addition to this, it was the realignment and construction of new access roads to the port. It was also the construction of rail access to the port, and also the construction of warehouses. So what we are going to do in this project, we are somehow going to simulate the same thing similar to the Port Botany expansion project. And the parts that we are going to focus are the construction of the terminal. So we are going to design a rigid pavement, the industrial floor for the terminal. The other part that we are going to work on is the realignment of the access road. We are going to design flexible pavement, different types of flexible pavements for the access road to the port. And also we are going to design new warehouses or the storage for the port. So here is the project that we have this year. So we are going to design new container terminal. We are going to design the slab for the terminal, the rigid pavement. There is one existing road here. So for this existing road, we plan to design flexible pavement because now the traffic has increased for the road. There is one existing traffic. There will be more traffic because of the trucks transferring the containers. So we need to determine the design traffic for the road, predict it. And after that, by predicting the design traffic, we need to design the flexible pavement for the road. And in the last chapter of the course, the thing we need to do is to design warehouses. So initially, before design of the structural components, we need to evaluate the strengths of the subgrade. But what type of soil we are dealing with in this project? We are dealing with two types of soils. The container terminal is on the reclaimed soil. This is the soil that borrowed from another area. They brought a good quality soil to the site. So we are going to evaluate the strengths of that soil. Also, there is one natural soil, and the access road is on that natural soil. So we need to evaluate the strengths of this natural soil. So part one is mainly coming from geotech engineering, right? And as a civil engineer, one part of your studies during your undergrad program was related to geotech. So you remember soil mechanics, applied geotech, they will help you in this part. So after subgrade evaluation, the second part is to determine the design traffic. You need to predict what is the traffic for the access road during the design life. This design life can be 30 years, 40 years, and or other values. After the determination of the design traffic, now you have the input data, subgrade, the CBR value for the subgrade, or elastic properties for the subgrade. Also, you know what is the load. This traffic is the load. Based on these input data, now you can design the flexible pavement for the road. And we are going to design different types of pavement. Then after designing the access road, we get involved in about week 5, we get involved in design of the concrete pavement or the industrial floor for the terminal. And in the last chapter of the course, in week 7 to week 9, we focus on design of the port warehouses. And they will have a steel structure. We are going to, and this part is related to the structural engineering. So for part 5, I actually invited a guest lecturer, a structural engineer, and he's going to teach you how to design the warehouses. So there is one question before I continue this part. Are we going to be taught how to design pavements? Yes, I'm going to explain you how to design pavement during the actually first 4 weeks. But in addition to that, you also need to go through the standards. And for more details, you need to go through the standards or other references to find out the answers to your questions. And here is the timeline for the course. During the, actually this week, I will give you an introduction to the whole structure of the course. Also, we go through subgrade evaluation. I'm not sure whether we can finish this part this week. We might continue this part next week also. In week 2, we mainly focus on design traffic for the road. Week 3 and week 4 are for the design of the flexible pavement for the access road. I briefly also explain you how to use software Circly for the design in week 4. In week 5, we will go through the design of the industrial floor for the terminal. Week 6 is the flexibility week. We don't have any lecture and demonstration class. In week 7, we focus on determination of the loads applied to the warehouse. The loads are the dead load, live load, and also the wind load. We are not going to consider earthquake loading because that's not a major load in Australia. The major dynamic load applied is wind load. And week 8 and 9 would be about the design of the warehouse. As I mentioned, I will invite the guest lecturer, Mr. Ahmad Jafari. He's a structural engineer. He will go through this part and will teach you how to design the warehouse. And week 10 is a self-study time. You can go through the project, work with your other group members, and finalize and write the final report for the course. About the assessment, there is no final exam for this course. You need to submit 4 reports. The first report, I also wrote here the deadline. The first report is about the evaluation of the subgrade strengths. Second report is about the design traffic and design the first type of pavement, which is the granular pavement with thin asphalt surfacing. There is also one individual contribution that I will explain, that I already explained that in the project description. I will also explain it later to you. And eventually, the main part of your mark is coming from the final design report, which should be similar to the one actually submitted in the industry. So this includes the main part of this final design report will be the design of pavement for the port access road, design industrial floor for the port, for the terminal, and design the port warehouse. I will provide you more details about each of these assessment tasks during the lectures. And also about the references. All the references that we are going to use are Australian standards, but we also suggest you some other references which can help you. The main reference for the first 4 weeks is Ostro's pavement design guide that you can see here. So this is the main reference for the first 4 weeks for the design of the access road, flexible pavements, and you can download this from the Ostro's website. You need to create an account in order to download this one, but it is free, so you can simply get that one from this website. I also brought 2 other references. This is the standards widely used throughout the world. This is the standards, the AASHTO standards used in United States and many other countries. So the most well-known standard for design of different types of pavement is AASHTO. We are not going to go through this one because the main standard used in Australia is ASTRO's. But if you're interested, you can also go through this one in order to learn and in order to compare your results with AASHTO. And the most well-known and famous book in this area is Pavement Analysis and Design, written by Yang Huang. And this book is also based on AASHTO. It explained details of the design, determination of the load, the distribution of stress and strain in the medium. So this is really a good book if you want to know more about the topic. If you face some questions and challenges during the project, you may find your solutions in this book. There are also some other useful references. You can find them in main roads. This is related to WA government. So there are very, very good references in this website. You can also go through that one and read more about the topic. For the industrial floor, for the terminal, when we want to design the rigid pavement, this is the standard that we are going to use. This is the Guide to Industrial Floors and Pavements, CCAA T48, which is widely used in Australia for the design of industrial floors. There are also 2 other standards, British Ports Association. These are very, again, popular, and US Portland Cement Association for industrial floors. But in this course, we mainly focus on CCAA. And for the design of the warehouse and the steel structure of the warehouse, these are the main references. They are Australian standards. The first 3 that you can see are related to determination of the load. So this part 0 is about general principles. Part 1 is about the determination of the dead load as well as the live loads. And part 2 is related to wind load. There are also part 3, part 4. For example, part 3 is related to the seismic analysis. Part 4 of the Australian standard, this is Australian standard 1170. And part 4, for example, is about the effect of snowing. And these three are the ones that we are going to use for design and determination of the load for the warehouse. And the other Australian standard that we are going to use for design of the steel structure is Australian standard 4100. So these are the main references for the design of the warehouse. All right, if you have any question about the structure of the course, about the references, about the assessment, please ask. If you don't have any questions, then I will go through the first chapter actually. So there's one question, is all the assessment task group work apart from individual design report? About the assessment tasks, so these two are group work, the submission of the first report and also second report. The third one is just individual, and it includes 15% of your mark. And the final design report can be, I will explain it later to you, can be individual or it can be submitted as a group. How many pages are you expecting for each report? I will give you the details for each of the assessment later during the lectures. For example, for the first one, the page limit is 5. So I will go through Moodle now and explain more details about this one. What is the individual contribution about? I will explain it just in a minute. How difficult would you say this subject is? Definitely it needs lots of effort. This is a real project. So as a civil engineer, as a final year undergrad student or a postgrad civil engineer student, later you will get involved in such project. As I showed you, the Park Botany expansion project was continued for 8 years, and 400 staff engineers worked on that project. So I think this course is the course which is very close to industry, very close to practice, and definitely it requires lots of teamwork, lots of self-study, as well as lots of time to spend on the project. I have a question about the number of group members, 3 or 4. The numbers are 3, so it is 3. Let me also go through Moodle and explain about the structure here, and I will also go through the project description. How many hours should we work per week? So there are 2 hours of lecture, 2 hours of workshop, but I think you need at least to spend something around 4 hours of self-study and working with your teammates on the project. So in total, it becomes something like 8 hours per week at least. All right, so about Moodle, here you can find the course profiles, timeline, the course program, the lecture hours, and workshops. So these are the online lectures, online workshops. In addition to online lectures and online workshops, I also created some virtual group study rooms for you. So the aim of these virtual group study rooms is that they are always open. So anytime you want, you can book that room and have a meeting with your group members. So this project requires lots of teamwork. These rooms, I created 5 rooms for you. You can simply book it here, book your virtual, just mention the name of the room as well as the time that you want to study there. So other students will know that they shouldn't interrupt you during that time. You can have a meeting with your friends there and discuss the progress of the work. You can um, share your files with them, and you can also share audio and video to discuss the progress of the project. In addition to that, we have one student discussion forum that you can ask your questions from other students. And this is mainly for yourself. So you can ask your questions, and other students, if they know the answers, they can help you in that part. Of course, you cannot ask the questions that we have as the part of the assessment of the course. But you can ask, for example, which reference are they using, if they suggest you any advice about the references, and so on. So this is totally for yourself. You can ask your questions. Other students can come and answer your questions. And if you need any help with the studies or life, there are some links that I provided for you here from UNSW and also for the support services. About the project, let's go through the project description. So here I gave you an introduction about the importance of the project, about what exactly we are going to design, and these are different tasks that we are going to do. We start from the evaluation of the subgrade strengths, then determination of the design traffic. After that, design of 3 different types of pavement. Then design the industrial floor, design of a rigid pavement based on CCAA standard, and eventually the design of the warehouse. So some students asked about the individual contribution. The individual contribution, as an individual, you can contribute to an issue not considered or treated in depth in the group work. So you can pick the topic, and in 3-4 pages, you can work on that topic. Here I brought some suggestions for you. You can pick one of these topics, or you can pick your own topic related to this project. For example, you can do some research about the risk management in this area, sustainability, environmental impact, economic feasibility, constructability and construction management. About the structural failures, the common structural failures occurs in this type of project. About the impact of heavy rainfall, which is a major concern, for example, in Sydney, what will happen, what exactly you need to consider and take into account as a civil engineer in order to prevent failures in different structural components of the port. The other problem that you can contribute as an individual is about the water management and drainage challenges. Or you can work on impact of large ground motion, like seismic loading. What if we want to make this port in a city which the major load is a seismic load? Which guideline do you suggest? What exactly we need to consider? What would be the effect of this seismic loading on the design? Or you can use other methods of analysis and design and comparing the results with your group work. For example, here we are going to use Circli for determination of stress strain and design the pavement. In parallel to that one, you can conduct a simple finite element analysis using, for example, Abacus, using Plaxis, and conduct a numerical analysis and discuss the results and compare the results and analysis with the ones you did as a group. And here are the different parts of the assessment. First report, second report, these are the group submissions. We have one individual design report, individual submission. The final design report is actually individual submission. So each of you need to submit individually, or there is an alternative method that we defined this year for you. So the alternative submission method for task 4 for the final design is that you submit a group report. But the important thing here is that if you prefer to submit a final group report, you should note that each individual student needs to effectively contribute to every section of the project. And because of that, you need to actually submit a declaration form. I uploaded the declaration form for you in Moodle. So the important part of this declaration form is part D, that you need to declare that all individual members of the group have had effective contribution in every section of this group. If one student doesn't contribute to the group report, or for any part he doesn't contribute, he or she doesn't contribute to that part, then he will not get marked for that specific part. And about the assessment 1, I will explain this assessment 1 at the end of the lecture, which is about subgrade evaluation. I will go through that one, but since one of the students asked what's the page limit for each report, after finishing each lecture, I will provide you with more details about each of these assessment tasks. For example, here for the first assessment, I provided details. For example, for the first one, there is a maximum length of 5 pages. And I also explained you which font you need to use, what should be the line spacing for preparation of the report, and so on. And for the submission of the report, you need to submit it through Turnitin. So here is the link for the submission. It would be maybe easier if I switch the role to student. So this is assessment 1, for example. This is the due date, the details for assessment 1, subgrade evaluation. And here you can submit the report. These are the material for the first week, introduction, as well as the subgrade evaluation. And these are the standards and documents, some of them. All right. So let me see, I see more questions from you. For the traffic, do we just need to determine the traffic flow? Do we need to design the traffic light using some special software? I will explain you in lecture 2 how you can determine the design traffic. Can we pick several topics to talk about in our individual contribution? No, actually, it's better that you just select one topic because it is just 2-3 pages of writing. And these are very important and fundamental topics. So just pick one of the topics that I gave you, or you can come up with your own topic, and the whole individual report should be about that specific topic. There are 3 tasks in the final design report. If we choose to make it as a group work, is it okay that one person take one single task? No, this is not possible. As I mentioned in the declaration form, all individual members of the group should have effective contribution in every section, right? So every week we will teach you one task, one part of the project. And my suggestion is that you should have an online meeting or face-to-face meeting if you are in Sydney, sit and work on that part of the project together, right? So you should have in the effective contribution in every task. It is not possible that one student just focus on design of the warehouse and not get involved in, for example, design of flexible pavement. All right. So do you have any more question about the structure of the course? Great. So let's start the first chapter of this project. The first chapter is about the subgrade evaluation, and we start from the design of the access road. And for the design of the access road, we need to evaluate the strengths of the soil, the natural soil. So in the first part, we are going to focus on subgrade evaluation for both reclaimed soil as well as the existing natural soil. So in this part, I'm going to give you a brief introduction to the structure of the pavement, because we are going to design 2 types of pavement. One, rigid pavement for the terminal, port terminal, and we are going to design a pavement for the the access road. So initially, I start from the I give you introduction about the structure of the pavement, then I will talk about the different types of pavement, and after that, I will explain about the different tests that we need to conduct to determine the subgrade strengths. So this is the classical definition of pavement in engineering. Any improved surface provided to carry any traffic supported on natural or improved soil is called pavement. The main purpose of pavement is to transfer the load and distribute the load to an acceptable level. Other aims of design of pavement is to provide a smooth surface for you and also provide a proper drainage condition for you. So why do we design pavement? These are the main aims. If we don't design, we can't have such a situation, right? So in order to provide a smooth surface, a good drainage boundary condition for the problem, and also properly transfer the load to the lower layers of the soil, we need to design pavement. Here you can see the structure of a flexible pavement. So at the bottom, we have the subgrade. This subgrade can be a natural soil, it can be a stabilized soil, or other types of material. After that, we generally have subbase and base layers. These are generally granular materials. For base layer, we generally use the cemented material. And after the subbase layer and base layer, we will have the top layer. The top layer in flexible pavements is generally asphalt. In rigid pavement, this layer is generally, it is actually concrete. So about the stress distribution. The primary function of a pavement is to spread the wheel loads to the subgrade. So as you can see, the initial load that we have is a concentrated load. If you directly apply this concentrated load on a subgrade, you will get a settlement, a deformation. If the number of the repetition of the load increases, so the number of the load increases, the level of permanent deformation in the system will increase. And it reached to an unacceptable level. So in that case, the surface won't be smooth anymore. We will have an uneven surface. So because of that, what should we do? The thing we need to do is to distribute this concentrated load with a large magnitude in a large area. And that load should be acceptable for the subgrade. So how can we do that? By the design of the proper thickness for the layers, for the surface layer, base layer, and subbase layer. So we have a concentrated load. You can see that at the bottom of the surface layer, when you use a proper thickness, this concentrated layer will spread out a little bit, but still the magnitude is not acceptable for the subgrade. So then we use base layer. Again, we distribute the load. And then we use subbase layer. And as you can see, now we somehow have a uniform load. It is the load spreads in a wide area, and the magnitude now is acceptable for the subgrade soil. So this is the main aim and the primary aim of design of pavement. About the loads, the concentrated loads from the wheel in light vehicles is something around 240 kPa. And for heavy vehicles, this load is something around 750 kPa. This is actually the standard load used in Astros, single axle dual tire load. But what is the bearing capacity, the typical bearing capacity of the subgrade or the soil? The typical bearing capacity is something around 350 kPa. So as you can see, this bearing capacity is larger than the typical load from the light vehicles. This is the reason that when we want to design pavement, we generally ignore the load from light vehicles. So when we want to determine the design traffic for the road based on Astrodes, when we want to determine the design traffic, we only consider the load from the heavy vehicles and we ignore the light vehicles. Even though the number of the repetition of the light vehicle loads is much more than the heavy vehicles, generally the load from heavy vehicles is much larger, and because of that, we will get permanent deformation in the system. But this bearing capacity, as you know, depends on the type of the soil as well as the drainage condition we provide for the soil. You remember from soil mechanics and applied geotech that the shear strength of the soil is different in different drainage conditions. For example, in drained condition and undrained condition, we will get different value. So the same thing is here. For the subgrade, the bearing capacity depends on the drainage condition and also the type of the soil. In some areas, for example, in Western Sydney, we are dealing with soft reactive soil. And in some cases, the bearing capacity is as low as 20 kPa. So very, very small value. Even light vehicle can cause permanent deformation and large settlement in the road. So what should we do? We need to design a proper structure for the pavement. Probably initially we need to improve the strength of the material by, for example, stabilization of the soil. And after that, we need to design the proper thickness for different layers of the soil. Also, as I mentioned, the strength of the material, because soil is a multi-phase mixture. It's a mix of solid phase, water phase, and air phase. So we know that the amount of water in soil will affect the mechanical behavior, the strength of the material. The most susceptible and vulnerable case generally is the case that the soil is fully saturated, and then the condition, the drain condition is actually undrained condition for the soil. In that case, generally the strength of the subgrade will reduce. Therefore, if for example, you are designing a road in an area with heavy rainfall, generally to consider the undrained condition for the subgrade and design and determine the undrained or bearing capacity of the soil. So here are the definition of different layers of pavement. Subgrade is considered as the foundation of the pavement. It can be natural, modified, or selected fill. And we generally need to compact the subgrade soil before the construction of the pavement. And if we are dealing with a soft soil, then we generally need to stabilize in order to increase the strength of the soil. The next layer is subbase layer. Subbase layer is considered as the main load-bearing layer of the pavement. The quality of the material that we are using is not that high. Generally, we are using granular materials, aggregates for that subbase layer, and the quality of the material is generally low for that layer. And this is an optional layer in the road. Depends on the level of or the amount of the traffic. If we are designing a light traffic road, generally we ignore the subbase layer. We don't need that one. Just with the surface layer and base layer, you can distribute the load, and the level of load will be acceptable for the subgrade. But if you are designing a pavement for a heavy traffic road, then in that case, we generally need to design and consider subbase. Next layer is the base course. The quality of the material we are using for the base course is generally high. So we can use granular materials, unbound granular materials, or we can use bound material. By bound material, I mean the material, the cemented material. So the particles have been stick together, right? So we will have cemented material, or we can have unbound granular material. Generally, for this part, we are using actually very high quality materials. We need to compact the base layer very well, and we need to use high strength aggregates for that. It is very important that the base layer should be well constructed and have uniform strengths. So if it doesn't have uniform strengths, then we will have uneven surface. At one part, the strength is high, therefore there is no settlement. At another part, we will have low strength, therefore we will get larger settlement in the road, larger permanent deformation. Therefore, we will come with a wavy road, right? So it is important when you construct the base layer, you need to provide a uniform strength. And also you should keep in mind that the design of base layer is very important. If you do not, for example, provide a proper thickness for the layer, that can cause permanent deformation at the surface, and the cost of repair will be very high. So we need to be very, very careful for the design of the base course. But what can cause this type of wavy road for us? If you do not consider a proper thickness for the base, if you use poor material quality for the base layer, if we don't provide and we don't design proper drainage condition, if water traps inside this layer, then there will be a big problem for us. Or when during the compaction, you don't reach to maximum dry density. You don't reach to optimum moisture content. So the lack of adequate compaction can also cause failure of the pavement structure. After that, we will have the surface course. So there is a general rule. When we come from the bottom layer to the top layer, the quality of the material that we are using will increase. So the best and the highest quality material that we are using is related to the surface. So this layer is in contact with traffic load. It is the highest quality, it contains the highest quality material. For flexible pavements, we are using asphalt, or we can use bituminous spray seal. And these are the main aim of design of the surface. It provides friction for us, smoothness, noise control. It also resists rot and shoving. These are two of the most important modes of failure of the pavement structure. And also, it should provide us a good drainage condition. So about this rot and shoving, these are permanent deformation at the surface. Here you can see the photos from these two types of failure. These are considered as the failure of the pavement structure. This is rotting that you can see, the permanent deformation lines along the wheels. And here we can see shoving. Again, a permanent deformation in the road, uneven surface. Why do these two types of these two modes of failure occur. The reason is that the structure that you have designed is not acceptable. It's not adequate. The thickness of the layer is not adequate, or for example, the materials that you have used are not good materials. They don't provide you the sufficient strength. And the other reason is that when there is a poor bond between the pavement layers, so they have to have full interaction with each other. The surface layer with base layer with sub-base layer, and sub-base with the subgrade. So let me see if you have any questions about this part. If you have any question. All right. So let's have a break for about 5 minutes, and then I will talk about the different types of pavement, and then start talking about the subgrade evaluation. During this time, if you have any questions, please write it down in the chat. Let me show you. So here, this is the chat. You can simply write down your questions. And after the break, I will go through your question and then continue the rest of the lecture. Do our best, me and my team, to resolve the problem. All right, there is one question about the reports, submission of the reports. How many times that reports can be submitted? Before the due date, there is no limit. I don't think there would be a limit for the Turnitin. When I created that one, I didn't define a limit for that. So you can submit it before the due date, as many times as you want. If there is any problem, please let me know and I try to resolve the problem. And should we add the declaration form at the end of first and second report? Yes, please. You need to, for any group reports, you need to submit this declaration form and declare that all the members of the group have effective contribution in every section. How much technical knowledge of concrete steel structure should we know for this course? It's been a while since I last looked at those subjects. So in this course, we do our best, me and my team, the demonstrators, to teach you everything that you need for that project, right? So we are going to go through all the fundamentals, teach you the design methods and everything. But in addition to that, for sure, there are some details that you need to get back to the materials that you had before for other subjects, and you need to go through the different standards and guidelines to find your solutions. But we are going to provide you with the details about the design of each part. In the design of the warehouse, can we select materials by ourselves, like designing the concrete beam and column instead of designing the steel stuff? My answer to this question is no, because in that case, this means that during week 7 to 9, the materials that the guest lecturer is going to cover won't help you at all. So it is better you follow the structure of the course, and the aim is to design a structural warehouse. So in practice, it is also like this. They will ask you to design this type of structure. You cannot change that one, but this can be a part of your individual contribution. If you want, you can, as an individual contribution, you can design the warehouse using concrete beams and columns. So if you don't have, all right, if you don't have any further questions, let's continue the about the software. It's up to you. If you prefer to use the guest lecturer is going to use a Spacecast, but if you want, you can design it based on Strand 7, no problem. For the structural design, yes, you have the drawing task. For pavement, it is not that important, but eventually you need to show the structure of the pavement. That's very simple to show, just showing the thickness of layers and so on. So we will provide you more details during the lectures related to that part. All right, I will go through the rest of your questions if you have any at the end of this lecture. Let's now continue the rest of the lecture. So far I talked about the structure of the pavement. Now about the types of the pavement. Generally we have two types of pavements. For most of the roads, more than maybe 98% of the road in Australia, we are designing flexible pavements. What do we mean by flexible pavement? These are generally the granular material that we are using, and at the surface we are using, for example, asphaltic layer. Why do we call it flexible pavement? Because the level of the settlement, the level of the deformation that we have is considerable, right? In comparison with rigid pavement, that the settlement is almost zero. Due to the difference, this is a big difference between settlement. Due to this difference, we will have different distribution of load, as you can see. In flexible pavement, we have somehow compression at the top of each layer and tension at the bottom of the layer. While in rigid pavement, you can see that in the top layer we have compression, and in the second layer we have tension. So in flexible pavement, in order to reach to an acceptable level of load, this figure shows it better. In order to distribute the traffic load to an acceptable level for subgrade, for rigid pavement, we only need one layer, one slab. Generally, we don't need to design base and subbase. Just one concrete slab at the surface, and that will be enough for distribution of the load, the concentrated load. This is like the pavement for airport runways. But for roads, for general access roads that we have in many countries, in Australia also, we are using flexible pavement. And for flexible pavement, we need several layers to distribute the load in order to reach to that acceptable level. In addition to these two types of pavement, there is also another type, which is the mix, which is the combination of flexible as well as rigid pavement. This type of pavement is called composite pavement. So as you can see, the first layer is coming from flexible pavement, is hot mix asphalt, and the second layer is concrete. And the concrete have base and subbase. Again, base and subbase is optional, depends on the level of traffic. So we are designing a high traffic road or light traffic road. So here is the design process for the access road. This is the process that pavement engineers and general civil engineers follow for the design of pavements. Initially, they need to determine subgrade strengths. They show subgrade strengths in terms of CPR that I will define it in a minute, or they are defining that one in terms of elastic properties, like modulus, shear modulus, and point ratio. So after evaluation of subgrade strengths, next step is to choose the type of pavement. For the access roads, generally are for the regular road, generally is designed flexible pavement. So here you decide which type of pavement you want, whether you want to design, for example, subbase layer, consider subbase layer or not. So as a civil engineer, you usually decide which layers are essential for that road. After that, you decide about the types of material you want to use for each layer, whether you want to use bond material or granular material, non-granular material. And then, again, as a civil engineer, you need to determine the strength of those materials that you are going to use for different layers, subbase, base, and asphalt layers. After that, we need to determine design traffic. You need to predict how many vehicles, how many heavy vehicles are going to pass through that road during the design life of the road, and what is the magnitude of those loads. So you need to determine the types of loads, the level of pressure, as well as the number of repetitions of the loads during for the design life of the road. So these are the input data. You now you know what is the load, what is the type of material you want to use, and what is the strength of the substrate. After the determination of these three, then you can design the structure, and you can select the most economical pavement thickness. And I should note that here that there is not just one unique solution to that, right? Different pavement engineers, different civil engineers can design different types of pavement. Maybe someone increases the base layer, decreases the sub-base layer thickness, right? So there is not just one unique solution. So the final aim is to select the most economical pavement thickness. So is there any problem with my microphone? Can you hear me properly, or there is no problem? Because can you please let me know? All right. Thank you. Thank you very much. In the next part, we are going to focus on evaluation of substrate strengths. So I already defined the substrate is considered as foundation of the pavement. In order to characterize substrate strength and stiffness, there are two parameters that we can use. One of them is called California Barrier Ratio, CBR. You can see the CBR value almost in almost all the guidelines related to the pavement design in hospitals. All the charts that you can see, most of the charts that you can see are based on the CBR value. So I'm going to explain what is the CBR value here in detail and which tests we need to conduct in order to determine the CBR value. So the definition is very simple. It's a ratio, the comparison of the strength of the natural soil or the side soil that you're dealing with to the strength of one standard material. It's the standard material of the crushed rock that we are considering. So it's just a ratio, strength of side soil to the strength of the standard crushed rock. And I will define what is this standard crushed rock? What is the strength of this value? This type of material. When we use CBR in our design, there are two cases. When you are designing a new pavement or concrete pavement, and when you design flexible pavement using empirical equations. We call this empirical flexible pavement design. So there are two methods of design on hospitals. One is empirical flexible pavement design. The other one is mechanistic flexible pavement design. So for empirical design, we are going to use CBR value. Another set of material parameters that we are using to characterize substrate strength and stiffness are elastic properties. Again, if you go to the hospitals, you can see that for mechanistic design of flexible pavement, we need to determine the Young modulus. The Young modulus, the Poisson ratio, as well as the shear stress. That I will explain you these material parameters. In addition to mechanistic design, when we want to conduct numerical analysis, for example, when you use abacus analysis, or you want to use, for example, Praxis for analysis of pavement, you need to use material properties like elastic properties, like unresolved Poisson ratio. So for fine method analysis, you also need these set of material parameters. How can we determine this? Generally conduct tests to determine CBR value, and then we use some empirical relations to determine elastic properties. So there are some relations with CBR and for example, the unusualness of the soil. Alright, which factors affecting substrate strengths? We want to see this substrate strengths depend on which factors. The first factor is the variability of the soil, type of soil. This is obvious. So we can have different types of the soil. This is not like a structure. You just deal one type of soil. This is a road. So for a road, this is actually the road level. And you can see that along the length of the road level, the type of the substrate that you're dealing with is always changing. As a civil engineer, you need to decide whether you consider the minimum CBR value or the strength for the weakest soil, or you want to change your design, pick some layers for each part of the road, right? So let's say that this is one example of variability. We can have variation in topography, we can have variation of the soil type, as well as we can have the variation of the draining condition. And variation of all of these will affect the strength, substrate strengths. What is the example? For the first zone, this is the first zone. For the first zone, we need to determine the CBR value for soil A, right? Because main part is soil A. Therefore, you need to take into account and determine the CBR value for soil A. For part 2, can you tell me which for which layer need to determine the CBR value? For which type of soil? You can see that the part is again A, soil A, but the thickness is not that much, right? So the thickness is not that much. Therefore, for part 2, the answer is correct. You need to take into account CBR A as well as CBR B. If, for example, the soil A is soft soil, so the strength is not that much, maybe it's better you remove that part and reach to soil B, or fill that part with a better quality soil, right? So for every section, you need to decide what you are going to do with that type of soil. Whether the CBR value is adequate, or you do, for example, latize soil, remove the weak soil, and so on. For part B, can you tell me which soil you need to determine? Which soil you need to evaluate? For part C, as you can see the level here. So you need to determine, and we need to fill this part. So you need to determine the CBR field as well as CBR B. Right? There are two types of soil. But because the thickness of the first layer is not that much, for sure you need to take into account the value of CBR B. This is for third one. Fourth one, Can you please help me with that? Which soil? CBR yield, exactly. For the fifth one, again, since the thickness is not that much, you need to consider CBR fill and CBR B. For the sixth one, CBR B, exactly. For the seven, PNC, that is correct. For the section 8, you need to determine CBRC exactly. And the last one, for the 9 section, again, here, the thickness is not that much, so we need to determine C and D. Right? So you can see that we have variation of subgrade strength. It's not like just conduct it at one specific point and then determine the subgrade strength. At different sections, at different parts of the road, you need to conduct tests and then decide whether you want to increase the value of CCR or you want to change your design of pavement. So there's no question why CCR did not be taken into account in the first part. This is just an example. I assume that this distance is adequate, so it's large enough, right? So I assume that the thickness of the soil A is large enough. That's the reason I didn't consider soil type B in the analysis. I will give you more details about this one. Actually, I will introduce you the Japan method. This is for the case that you have 1 weak layer below the soil. So let me see. There was actually another question. I think we missed one question. For the subgrade material, do we use in situ only if proof roll testing passes? Just wondering if we always have to use other material when fails in deflection test. So you need to determine the CBR value. This is a good question. So they ask whether we need to use in situ value for the design, or we need to actually use other material. This depends on the project. So which type of material you want to bring, how much you can increase the CBR value for that road. These are the questions that the engineers should answer for that specific project. Also, whether bringing that material to the site will be costly or it would be cheap, or can add different additives to the soil in order to increase and stabilize the soil and increase the CBR value. So there are some requirements in ASTROs. For example, if the CBR value is below 3, this is not acceptable at all. Yeah, you need to stabilize the soil or remove that soil. But if the CBR is, for example, 6, 7, I will explain later, it is up to you whether you want to increase that value and reduce the thickness of the layers, or you want to consider the CBR as is. So let me also answer the other questions. We'll go through them very fast. After that, I need to continue the rest of the lecture. Why is CBRB not taken into account in the first part? What thickness would you consider as small enough? This was just one schematic example that I showed you here. So I will explain you later in more details. But generally, if there is a weak layer in the soil, we need to calculate the CBR value for at least 1 meter below the surface. So if you allow me, I continue the rest of this lecture, and at the end of the lecture at 8 p.m., I will go through your questions. So the first factor affecting the subgrade strength is the variability of the topography, soil type, and drainage condition. The other terms which affect the subgrade strengths are field density and the moisture content. So you remember from soil mechanics that we need to conduct compaction tests in order to determine the maximum dry density and optimum moisture content of the soil. And then we need to compact the soil as close as possible to in the site in comparison with the one in the laboratory. So we need to reach to that maximum dry density in the site. So what will happen is that, look at here the result. At maximum dry density and optimum moisture content, we somehow get the maximum CBR value, something around 16. And as you can see, by the decrease of, for example, increase of moisture content or decrease of moisture content, the value of the CBR will reduce significantly. So generally, we prefer to compact the soil and reach to maximum dry density in order to get higher level of strength. And that depends on the moisture content of the soil. And we know that when the density increases, when gamma T, gamma dry increases, it means that the interaction between the particles will increase. Therefore, the friction between the particles will increase. And you remember that the strength of the soil, tau u, for example, you remember more Coulomb from soil mechanics or from fundamentals of geomechanics. When friction between the particles increases, the strength, the shear strength of the material, the shear strength of soil will increase. So these are the other two important parameters which affect the subgrade strengths. There are also other factors affecting. These are mainly related to the moisture changes during the design life of the road. For example, the amount of the rainfall, again, it will affect the strength of the material. Whether we are dealing with reactive soils are the type of the soil which are sensitive to the change of moisture. By increase of moisture in the soil, the soil will swell. These are the type of the reactive soil that we are talking about. The permeability of the soil will also affect the subgrade strength. So lower permeability, water can trap inside the soil for a longer time, and that will affect the subgrade strength. The other one is the relative permeability of the pavement layers. So you might have one gravel layer at the top, the permeability is very high, but on the other hand, you have one cemented material at the bottom, the permeability is very low. So again, the water can trap in that layer. And of course, the depth of the water table will affect the results. So these are different terms which can significantly affect your results. And the best solution to overcome these problems is to provide a good drainage condition. So you need to exclude water. When you exclude water, you are increasing the value of the strength of the soil. And what will happen if we have this moisture? This moisture can cause a failure, different modes of failure in the road. And here you can see some of the examples. It will definitely reduce the pavement strength. In concrete pavement, it will cause pumping and decracking. Decracking you can see here. In asphaltic pavements, it can cause stripping. This is the case that the aggregates lose their bonds. So it will cause such failure in the road, as you can see here. The moisture, when the temperature can get below zero, we can have frost heaving. And in the areas that we are dealing with reactive soils or swelling soils, we can have soil swelling. This is, for example, in Western Sydney. In Western Sydney, we have swelling soil. So all the time, it's a problematic soil, type of soil that we are dealing with. By increase of moisture content, the soil will swell, and that can cause this type of failure in the road. We will have uneven surface when you don't treat reactive soil. But how can we determine the CBR value? There are different types of tests, in situ tests as well as laboratory tests. We have the most popular ones are in situ as well as undisturbed CBR tests, laboratory tests. The other tests that we have are dynamic cone penetrometer, static cone penetrometer, electric friction cone penetrometer, Clegg, hammer test, falling weight, and these are different types and for different thickness, for different depths. So you can see that the CBR test is generally for the surface, but dynamic cone penetrometer can be continued on up to 2-meter depths. And we have the laboratory test, the CBR test on undisturbed sample or on remolded sample. We can conduct triaxial tests. Generally, it would be more expensive to conduct this type of test at different range of saturation degree. And there is also one indirect method to determine and calculate the CBR value from the classification test, like sieve analysis and also Atterberg limits. You remember them from soil mechanics and fundamentals of geomechanics. But in this course, we are going to focus on CBR test. This CBR can be in situ or laboratory. Also, we are going to focus on dynamic cone penetrometer test, as well as calculation of CBR from classification tests. For minor projects, when you are designing the pavement for lightly trafficked roads, sometimes you might not conduct any test and you can use some presumptive values provided by Ostrows. So as you can see, these presumptive values depend on the type of the soil that you are dealing with. So you need to conduct sieve analysis as well as the Atterberg limit tests to determine the type of the soil. And based on the type of the soil, you can use this table. Again, you can see that the CBR value depends on the type of the drainage condition you can provide for that road. If you can provide excellent drainage and you can exclude water from soil, Ostrows allows you to use higher values for CBR. For example, for highly plastic clay, the value suggested by Ostrows is 5. But if the drainage conditions is poor, then the value you need to consider will significantly reduce to 2 and 3. But remember, this is only for the case that you're dealing with a minor project for lightly trafficked roads. So the first group of tests are in situ and laboratory CBR tests. Here you can see the equipment. This is for the laboratory test, and here you can see for the equipment for the in situ CBR test. So the test is very, very simple. As I mentioned, for determination of the CBR, we need to compare the strengths of the soil with the strengths of a standard material. This standard material is a well-graded crushed stone. So if you conduct the test on this standard material, these are the values that you get. So you are applying a load. The load will increase, and we will have the penetration of the cone inside the soil. The rate of penetration is constant. So this rate of penetration in this test is constant. It is something around 1 millimeter per minute. So with a constant penetration rate, you start applying the load and you record the load values that you're applying. And based on that, you can determine the CBR. I will explain you in a minute how to determine the CBR value. As I mentioned, CBR is the ratio of the strengths of the site soil to the strengths of this standard material multiplied by 100. So it's a ratio, it's a comparison of these two values. And for standard values, this is the penetration of plunger and the equivalent load, the corresponding load to these penetration level. This test was developed by California Division of Highways in the United States in 1930s and widely used in all over the world in US, UK, Canada, Australia, New Zealand, and many other countries in the world. In almost all the standards and guidelines for the design of pavement, you can see this CBR value. And as I mentioned here, nearly all design charts are based on this CBR value. And here is the principles. Here is the test procedure for this one. So the method is applicable to fine grain and medium grain soils. If the size of the aggregate is very large, in that case, this type of test is not applicable. You cannot use that one. Here you can see the schematic figure from the apparatus in the laboratory. So this is one mold. The size of the mold is 100. The size of the sample inside the mold is 152 millimeter height. Sorry, 175 millimeter height and 152 millimeter as the diameter. After preparation of the sample, you need to you need to compact the sample after putting in the mold. You need to apply a surcharge at the top. How much should be this surcharge you're applying? This should be equivalent to the mass of the pavement. So based on the pavement weight, you need to apply a proper level of load at the top of the soil sample. Then you install the plunger and start applying the load. The diameter of the plunger is something around 50 millimeter. And you need to apply the load with the constant penetration rate of 1 millimeter per minute. And if it's a manual test, then you need to record every 0.5 millimeter penetration. You need to record the applied load. But most of the equipment that we are using these days are automated, so they automatically record the load. So very simple test, very cheap test. This can be conducted just with one person at the site. and you can collect lots of data within a day. As I mentioned, the drainage condition and the moisture content can significantly affect the CBR value. The CBR value can change by change of the moisture content, right? This is the change in the moisture content. The CBR value, for example, can be 16, but here can be 10. Big difference because of change of moisture content. So when you conduct a test, you need to consider the same moisture condition for the sample. What should be this moisture? This depends on the median annual rainfall. How much rainfall do we have in that part of the in that area? And also it depends on the drainage condition, the testing drainage condition. So for example, for Sydney, the level of rainfall is very high. Therefore, you need to select, for example, if it's over 800 millimeter, then based on Ostro's, you need to compact the sample at 1 to 1.15 optimum moisture content. This is before test. And again, before test, you need to soak the sample, right? The number of days that you need to soak the sample depends on the drainage condition. If you can provide excellent to good drainage condition, you can conduct the test on unsoaked sample. It means that the water cannot trap inside the soil. The drainage condition is excellent. The water can get out of the soil very quickly, so it will not affect the strength of the material. But if you are considering poor condition, poor drainage condition, then you need to soak the sample for a longer time. Longer soaking time, it means lower CBR value, right? So when you soak the sample for a longer time, it will give you lower value of CBR generally. So these are the drainage conditions. You conduct the test, you start applying the load with this constant rate of penetration, and eventually the result that you get would be something like this curve that you see. It's load versus penetration. In order to calculate and determine the CBR value, so initially you plot load versus penetration. Then you need to determine loads at two penetration level. One is at the penetration of 2.5 millimeter, which is this point. The other one is penetration of 5 millimeter. So you can simply read these two values, read these two loads. What is the definition of CBR? CBR means comparison of the strength of the site soil with the standard material. So in order to determine the CBR, we need to compare these two level of loads with the load of the standard material. So we calculate the loads for these two penetration levels, and then we determine CBR 2.5 and CBR 5 by using these two simple equations. So load at 2.5 millimeter divided by load at 2.5 millimeter penetration for standard material. So after calculation of CBR 2.5 and CBR 5, if the CBR 5 is less than CBR 2.5, the design CBR becomes CBR 2.5. So you decide that, okay, this is the final CBR for this soil. But if CBR 5 is larger than CBR 2.5, you need to repeat the test. Why do we need to repeat the test? The reason is that generally CBR5 is less than, for most of the soil is less than CBR 2.5, because for this type of standard material, for this type of crushed rock, the increase in the level of load from 2.5 penetration to 5 penetration is very high. So it is highly unlikely that we have such an increase for the site soil. Generally, for the natural soil that we are dealing with, the increase of load is not this significant, right? So for a standard material, this increase is significant. Therefore, we generally expect that CBR5 should be, for our soil that we are dealing with in the road, CBR5 should be less than CBR 2.5. Therefore, if your results show that CBR5 is larger than CBR 2.5, you need to repeat the test. If again CBR5 is larger than CBR 2.5 on repeat, then you can consider design CBR as CBR5. Otherwise, your design CBR becomes CBR 2.5. Very simple procedure. It's not difficult. Let me show you on this example, and after that, I will go through your question and finish this lecture. For this example, for this simple example, for penetration, you need to consider penetration 2.5 and penetration 5. Then the loads, what are the loads? The load for 2.5 is 3.35, and the load for penetration 5 is 4.9. What are the standard loads? You can read them from the table. This is for the well-graded crushed rock. So the values for 2.5 is 13.2, and for 5 is 20.55. I wrote it as 20. So you can simply divide this by this one, and you can calculate the CBR value for 2.5 and 5. So based on this, can you tell me whether we need to repeat the test or not, based on the procedure that I explained? Do we need to repeat the test? No, exactly. That's correct. So we don't need to, because CBR 2.5 is larger than CBR 5. So the final CBR from this test becomes 25.3%. So that's all for today. I will continue the rest of this lecture on Tuesday. Now I'm going to go through your questions. So let me bring the question. So why CBRB? Okay, I answered that question. What thickness would you consider as small enough to not account for the soil? The thickness, it depends on your engineering judgment. So generally for 0.2 meter thickness, if the soil is weak, you need to get rid of that layer. But it depends. It depends on the project. If the layer at the if there is a weak layer at the bottom of the surface layer, in that case, for at least 1 meter depth, you need to take into account the effect of the weak layers. So I will cover that part later when I explain the Japan methods for you. The next question is that why the last one should consider CBD. Let me get back to that slide. All right. So this is just one schematic example that I showed you. I assume that in this zone, the CBR, the thickness of layer C, soil C, is very small. And because of that, I also took into account the CBR for layer D here. Later, when I explain you the Japan method, you will find out when you should take into account the effect of layers below the surface layer. So the next question is that why is CBR fill not taken into account in the last part? In the last part, yeah, I ignored this zone, but if you want to consider this zone also, it might be better you define the section here. So divide this section to 2 subsections, right? This depends on you. So the other question is that why does 9 have no fill? Okay, part 9, it was, I think, the same question. For this part, if you want, you can consider the fill, or you can subdivide it to 2 sections, and for each section, determine the CBR value. Also, another question, is there always sub-base below base material? Can it be base material and then sub-base right after? So this is the definition of the layer. We consider base layer at the layer above the sub-base layer. But sub-base layer is generally optional, so you might ignore that layer in your design. So can it be base material and then subgrade right after? Yes. If you are dealing with a lightly trafficked road, if you are designing a light traffic road, in that case, we can ignore the sub-base layer. So we can have base layer at the top of subgrade. Do we need CBR test for all the layers? Below pavement, we determine the CBR value for the subgrade. Also, we can determine that one for the sub-base layer and base layer. I will explain about the determination of and design of sub-base and base layer later in lectures 3 and 4 to you. But at this stage, I'm just explaining the CBR test for subgrade. Will we be given a similar cross-sectional diagram like this when determining which CBR should be considered? Actually, here, the subgrade that we are considering, we don't consider any variation in the soil type. As I showed you in the project, we are just going to consider 2 types of soil. One is natural soil. The other one is the reclaimed soil that is the foundation of the terminal. So just 2 types of soil. We are not going to consider variation of soil in this project. So it's a simplified project that we are considering. So the next question, would we need a different load versus penetration plot for each layer? For the CBR value, yes, that's the case. For example, you might need to continue the test for at least 1 meter below the surface. So for example, here, you need to conduct the test for example, here, if we assume that this is, let's say this zone is 1 meter, then you need to continue this test and determine the CBR value for soil B, C, and D, right? So it depends on whether you expect that there is one weak layer at the bottom of the top layers or not. I will explain this one when I go through the design, the Japan method. Is empirical pavement design more widely used than mechanistic design in the project? Not necessarily. The empirical pavement empirical pavement design. Yeah, it is widely used for